here in this box on the right, we're going to write what our functions look like with a, h, and k in them. Okay, so the parent function for a line was just y equals x. And we're actually going to use f of x instead of y. We're going to start getting in the used to using that function notation again. Okay, but instead of just x, where would the a, h, and k appear? Okay, a is multiplied to the function. Okay, so a is the coefficient of x. Okay, and then k is that vertical shift up or down. Okay, so plus k. So this is like your mx plus b notation, wherein this would be your slope. Okay, what you multiply by is affecting your slope of your graph. Okay, the vertical stretch. Okay, and then k is shifting the graph up or down, so it's affecting the y-intercept. Okay, so for the linear, we don't have to have h in there as well. Now for the rest of these, we will. So the absolute value parent function, we multiply by a on the outside, and then when we say inside for absolute value, it's inside the absolute value bars. Okay, so x minus h is on the inside, okay, and then plus k is on the outside. Now remember, it's always going to be minus h for the standard setup of these equations. Okay, so that's why when if you plug in a h and we say, okay, it's shifted to the left or to the right 1, that means h is 1. But when I put it in the equation, it's minus 1. Okay, so in the equation, it's being subtracted. That's actually shifting it to the right. Okay, but then if I said it was left 2, h would be negative 2, but when I subtract a negative, it turns this into plus. So when it's adding in the equation, that's actually shifting left. So remember, the inside is going to be the opposite sign of what you would typically think. Now for a quadratic, instead of absolute value bars, what would I have? Okay, but what do I need to have to show what is squared? Parentheses, good. So it would be the x minus h that is being squared, okay, because that's inside the function. The a and the k are outside the function. Okay, now the radical or the square root function, what would I have instead of absolute value bars or parentheses squared? Yeah, the square root, the radical symbol. Okay, so inside is what's under the radical. So the x minus h is under the radical, and the plus k is outside the radical. Okay, what's the cubic going to look really similar to? Yeah, it's going to look really similar to the quadratic, but instead of squared, it will be cubed. Because it's a cubic function. Okay, how about the cube root function? What's that going to look almost identical to? Yeah. The only thing is, instead of just the radical, we'll have an index on the radical to show that it's not the square root, it's the cube root. When there is no index, it's understood to be a 2, so we know that's a square root. So cube root just puts a 3 there for the index. We still have x minus h on the inside and plus k on the outside. All right, now exponential. In an exponential function, where is x? The name kind of gives it away, right? In the exponent. Okay, so the a is multiplied on the outside. Now remember, when we did these parent functions, we said the base could be any number. So we just used a b to represent some base value raised to the power of x. But now the minus h is in there. So when I say in the function for an exponential, it's in the exponent. Okay, so the power of x minus h, and then the plus k is not in the exponent, Okay, that's a vertical shift. All right, logarithmic inside the function means what you're taking the log of. Okay, so we're going to have multiply by a. Okay, and then you're going to take the log of, and we use parentheses because it's not just anytime you have something with the x, we'll use parentheses. So the x minus h, okay, and then the plus k is outside those parentheses. So you're not taking the log of the plus k, you're only taking the log of what's in parentheses here. Now remember, you could also put a base on the log. If no base was written, it's the common log, base 10. But that base could be something else.
Sure.
Uh-huh.
So we don't multiply the a at this point?
You do. The a is still there. But the a is not inside the function. It's outside the function. The a is always multiplied outside the function because it's affecting the graph vertically. So the a and the k are considered outside the function. So they are changing the y value. Okay, the only thing inside these functions that we're looking at is the h, is the horizontal shift. It affects it horizontally. Does that help? Does that answer your question? Okay, when we get to some examples with numbers, maybe it'll start to make a little more sense. If it doesn't, you can ask about a specific question. Okay, so for the rational, what is the rational parent function? 1 over x. So if I multiply by a, that would just multiply into the numerator, right? 1 times a would just be a. And then inside the function would be considered in the denominator because that's where x is in this function. So x minus h down here, okay, and then your plus k. Okay, so you're going to use this little box. You'll refer back to this when you are asked to write the equation of a transformed function, okay, something that's not the parent function, okay, or you can look at it to see if the equation's given to you, what parts of it are a, h, and k to help you remember how they are affecting that graph, okay. These examples on the back are, there's 3 different types. We have a graph, and we were going to give the parent function or the type of function and what transformations took place, and then write that in one of these formats, depending on what type it is. Okay, so for instance, this first one is what type of function? Y'all have got to be able to see the shape of a graph and know what it started as. What parent function was it? What type? And right. That was a quadratic, right? That's the x squared. Graph's a parabola. Okay, so this is a parabola, but it's not the parent function of the quadratic, right? The quadratic parent function had a vertex at the origin. So this has definitely been transformed. How has it been transformed? It's shifted up, and that's at 5. Okay, so it's been shifted up 5. Has it been shifted left or right? No, because it's still on the y-axis. It's still symmetric about the y. Okay, still an even function. Has it been reflected? No. Okay, it's still opening up, so the a is not negative. Has it been stretched? No, and if you're not sure how to check that, here, I'll zoom in a little to help you see that a little better. Okay, the parent quadratic, 1 squared is 1, 2 squared is 4. So from the vertex, you should be able to go over 1, up 1, or over 2, up 4. Y'all see that? And that's the same thing. If I'm here, I go over 1, up 1, that's on my graph, or over 2, up 4. That's on my graph. So it hasn't been stretched because it's still got the same change from points there on the curve. Does that make sense? So that has not been stretched. It has not been reflected, and it has not been shifted left or right. The only transformation is that vertical shift. which is that your A, H, or K? That's your K. K is what is shifting it up and down. So looking at the quadratic over here, A, nothing changed. So it's going to be the understood one. So I don't have to write it. H, the horizontal shift, there is none. It's 0. Do I have to write minus 0? No. Okay, but the K is the 5. So it's just going to end up being x squared plus 5. So it's the parent function shifted up 5. Does that make sense? Okay, the next one is what type of function? This V shape. Absolute value. Okay, I'll zoom in again and y'all can tell me how this looks different than the parent function. Has it been shifted up or down? Left or right? No, it's still got the vertex on the origin, so no shift. So H and K are both 0, no shifting. Okay, has it been reflected? No, it's still opening up. It has not been reflected over the X. Okay, but the stretch, let's check that. Normally in the absolute value, I should say the parent function has a slope of 1 over here and -1 over here. Okay, so you could go over 1, up 1. Over 1, up 1, over 1, up 1. That's where the angle that the slope of that side would be at. But here, that is up at 3. When I go over 1, up 3 to be a point on that line. So that means what's happened to it? Is it compressed or stretched vertically? Because remember, a vertical stretch or compression, we're putting our hands on top and bottom. So if I had my hands on top and bottom of the parent function, is it like I pulled them apart or pushed them together? Pulled them apart. So I vertically stretched the graph to make it taller. So it looks longer and leaner, taller and narrower, okay, for a vertical stretch. Okay, and that's by a factor of 3. So a vertical stretch by a factor of 3. And that's the only thing. We said nothing else had happened to that. So in our function for absolute value over here, A is the 3. That's the vertical stretch. And we said H and K were 0, so we don't need to write them. So it's just going to be 3 times the absolute value of X. What is this function? That one's rational. You've got those two curves. Okay, and they're not drawn as dashed lines here, but they're the asymptotes that on the rational parent function are normally on both axes. There's still this vertical one here on the y-axis, so that has not shifted. But the one that's normally on the the x-axis has been shifted. It's up here where our graph is looking like it levels out to the left and right. Okay, so what value is that at? Yeah, so that asymptote has shifted up 5, but this asymptote has not shifted left or right. So that means there's no H. H is 0, but K is 5. Okay, this has not been reflected because we're still in the top right and bottom left corner. Okay, that's where the parent function belongs. If it had been reflected, those would have shifted. It would have been top left, bottom right. So no reflection. And then you can check for the stretch. There is no stretch in this one either, because from that point of intersection of the asymptotes, you can see there's a point at over 1, up 1, okay, or over 2, up half, or over half, up 2. Okay, those points still exist there, so there's no stretch happening or compression. Okay, so this one is just up 5, just like the first one. But this one is a rational function. So it would be 1 over x and then the plus 5. We feel okay about those? Okay, I think coming from the graphs are probably the tougher ones. Okay, this next section is given a description. We're writing the equation. Okay, so we're told the type of function, so it's cubic, so we know it's going to be that x cubed. When we look over here, we're going to be looking at this one right here. We need to figure out, though, what are a, h, and k based on the description given. So a vertical shift up 5. What does that tell me? Yeah, that tells me k is 5. Okay, a horizontal shift, that's h. Right 3 means h is 3. But remember, in the equation, that's going to show up as -3 because it's x minus h. So the h itself is +3 because it's to the right. But in the equation, it shows up opposite. It shows up as minus. They said nothing about a reflection or a vertical stretch. So that means my a value is just the understood 1. Okay, I don't have to write understood 1 though. So A does not need to get written. So I would say that this is x minus 3. And this is the cubic. So that's in the parentheses cubed. And then my plus k on the outside. So plus 5. Feel okay about that? Next up is a quadratic. This one has a horizontal shift again, left 8 this time. So that means h itself is negative, but when I plug it in, minus negative is going to change to plus. So in the equation, it's going to be plus 8. A vertical compression, so that's my a value being affected. It's being compressed by a factor of 4. So the a value is actually 1/4. Okay. For a to be a 4, that would mean it would be stretched by 4. So we're compressing by 4, which means a is 1/4. They said nothing about a vertical shift. So k must be 0, which we do not have to put plus 0 at the end. So this would look like 1/4. Okay, and then in parentheses, x plus 8. And this is a quadratic, so that's squared. Okay, if you have any questions in this format like this, you could always use Desmos and type in what you think it should be as one equation, and then type in the parent function as a second equation and look at them at the graph to get on the grid together and compare and make sure it meets this description. All right, then the next one is a radical function. So a radical reflected over the x, that tells me a must be negative. It says nothing about a stretch though, so it's still a 1, but it's negative because of the reflection. Okay, translated right 2, so again, that's my h is 2, nothing about a vertical shift, so k is 0. So a is negative, and then this is the radical, that's the square root. And then inside needs to be x minus h, so x minus 2. All right, last one of this type, exponential. Vertical, that's k. Vertical shift down 9, so it must be -9. And a horizontal shift left 1, so that's -1. Nothing about a reflection or a stretch or compression, so a is just the understood 1. So for exponential, I don't need a, it's an understood 1, but I would have whatever my base is, which I don't know, so base b, to the power of x minus h, so that's going to be x plus 1, right? The opposite, plus since it's to the left. And then minus k It's actually plus k, but k is negative, so that comes out as minus 9. Plus negative 9 is the same as minus 9. All right, and then the very last part is going in the opposite order of what we just did. We're going to be given the equation. We want to describe what type of function, what parent function was transformed, and what transformation took place. Okay, so let's go through. What did I do after paint blue? What type of function? Let's just get the types of functions listed real quick. What type of function is 6? Good. Okay. What type of function is 7? Cube root. Good. What type of function is 8? A log function. What type of function is 9? X is in the exponent. Yeah, so exponential. Okay, 10. That is just linear. Good. Okay, and then 11. That one is rational. X is in the denominator. Okay, so now I'm going to go through and I'm going to identify A, H, and K so that I can describe what transformation has taken place. Okay, so the A value here, what's being multiplied in front is the 2. H is the 1 because it's X minus H on the inside, and nothing added on the outside. K is 0. So no vertical shift. This is a shift right 1 horizontally. And then the A value, that's a vertical stretch. So a vertical stretch by a factor of 2. Does that one make sense? I'm going to identify A, H, and K again. That's always going to be my first step for these before I list the transformation. Okay, so no A value in front. It's an understood 1. So no reflection, no vertical stretch or compression. H is 3 and K is 5. So what direction are those translations? Right 3? Good. Right 3, up 5. Very good. All right. The log has an A value of -1. Okay, so the A is -1. The H is 7. And the K is 3. What does that negative A value do? Yeah, it's going to reflect over the x-axis. Okay, the H will do what? Right 7. And the K? Very good. All right, now for this exponential, the A value I can see is -3. The H value is 1. And the K value is -4. Okay, so first of all, the A has 2 changes here. It's affecting the graph in 2 ways. It's negative and it's not 1. Okay, so the negative means that it's the reflection over the x-axis. And what does the 3 do? That's a vertical stretch by 3. Okay, and the H, right 1. Okay, the H is left or right. Okay, and since in the equation it was minus, that means it's to the right. Okay, and then the k is -4. How does that -4 out there affect this? Down 4. Good. All right, now linear, if I identify A, H, and K, A is 10, there is no H, and K is 8. Okay, so if we're talking about how we've been talking about all these other ones, we would say, okay, this is a vertical stretch by 10. And it's shifted up 8. But if we're talking about in terms of how we typically talk about linear functions and how to graph them, what do that 10 and the 8 represent in the line? 8 is that's the y-intercept. And what's the 10 represent? The slope. So if you wanted to jot that down as well, we need to make sure we still remember it that way. All right, then last but not least, this rational function, do I have an a value? Yeah, it's the understood 1. Okay, an h, what 6? It's actually -6, because remember it's x minus h. So for it to be a plus, the h must have been negative, and there is no k. So no stretch or reflection, no vertical shift. There is just a horizontal shift. What direction? Left this time. Left 6, and that's it for that one. Okay, so hopefully those transformation rules are kind of coming back to you, sparking some memories from Algebra 2. We'll be doing some practice over these transformations tomorrow.